Hi guys, welcome back, and today I'm going to be solving the USACO 2016 December contest silver. Problem 1, counting hay bales. Farmer John has just arranged his hay bales up to 100,000 at various points along the one-dimensional road running across his farm. To make sure they are spaced out appropriately, please help him answer K queries up to 100,000, each asking for the number of hay bales within a specific interval along the road. So the first line contains N and Q, and then N distinct numbers, each in the range 0 to 10 billion. And then the next Q lines contain two integers, where A is less than B, and they're up to 1 billion, giving a query for the number of hay bales between A and B inclusive. And you should write Q lines of input, and each line of input should have the number of hay bales in its respective interval. So the problem is pretty straightforward. We start off with 4, which is going to be uh, the number of hay bales in the total, like in the total one-dimensional road, and 6 is going to be the number of intervals that we have to look for. So, and in each of these intervals, we want to see how many hay bales are in between these intervals inclusive. So we can see that there's a hay bale at 2 and a hay bale at 3, so we have 2 in total for the first input. For the second one, in the range 2 to 4, we have one at 2 and one at 3, so that's also 2. In the range 2 to 5, we have 3 hay bales, 2, 3, and 5, so that's 3. In the range 2 to 7, we have all of these 4 hay bales, so that's 4. In the range 4 to 6 inclusive, we only have one hay bale in the range, which is 5, at index 5, and in the range 8 to 10, we have no hay bales. So this problem is pretty straightforward. What I'm going to be using to solve this problem is, first of all, we're going to store all these values. Instead of creating an array that has each index representing an index in the one-dimensional road, I'm just going to create an index full of the integers 3, 2, 7, 5, and then I'm going to sort it. So it becomes the index 2, 3, 5, 7. And then for each of these queries, what I'm going to do is I'm going to use a method in Java called the binary search. And using this method, I'm going to find the index in the sorted array at which there is a 2. So I'm going to find the index within the sorted array that contains a 2 and the index within the sorted array that contains a 3. And if I just subtract the indexes and add 1, then I can find the amount of hay bales that are in this interval. Now the problem is, not all these numbers in the range are going to have a hay bale at that index. For example, 8, there's not going to be no hay bale at 8. So if we do a binary search method, which is going to return the index of this number 8, it's going to return a negative number. But what this negative number is it's basically going to be the index at which an 8 would be at, um, times -1 plus 1. So it's going to be the negative of the index it's going to be at. So all we have to do is multiply it by -1 and then add 1. So right now the method can seem a little confusing, so I'm going to code the initialization and the solving portion first, and then I'll display the method right after, so we can make sense of how we can use this method. And the method is going to be called arrays.binary search, and it's going to use a binary search algorithm to find the index of a specific number in an array. Oh shoot. First we have to do public class type of counting hay bales silver. So we're going to need a buffered reader since there are going to be a lot of input. We need a string tokenizer for each line. We're going to need a string builder, which is going to basically keep track of all the input and print it out all at once. And that's going to decrease the amount of time that it takes to compile. And we want a print writer to print out the output. Yeah. Then we need the integers and q. We also need an array, let's call it hay bales. And we need the integers a and b, which we're going to take in from the input at each of these lines. So we create our main. I'm just going to throw an I exception. So n equals a new buffered reader, new file reader, haybales.in. And for debugging purposes, for now, I'm going to set it as input stream reader. Okay. And then another comment, out is going to be a new print writer for the file haybales.out. And first, let's do our initialization, and we'll do this in a separate class for readability, and so that it's neater. So what are we doing? Well, first we're getting the integers n and q, right? So we need a string tokenizer to get each of these values with a buffered reader. And n equals integer.parseInt st.next token. And it's the same thing for q. And then we initialize the array haybales, which is going to be of length n. So they're going to be n haybales, and then we set up the string tokenizer again. Then we fill the array. So for int I equals 0, I is less than n plus haybales at index I equals integer.parseInt st.next token. So the next integer in this line. And then lastly, we just have to sort hay bales. So arrays.sort hay bales. Now let's do a solving portion where we're going to use a method called arrays.binary search. So sp equals new string builder, since we're going to need to um, add the answers for each of the lines, so the output for each of the lines to the string builder as we go through this for loop. And for each of these queries, or the number of lines, we're going to have an integer a and an integer b. So we need a new string tokenizer. And we need so a, we have to initialize a equals integer.parseInt st0, and b equals the same thing. And now what we're going to be doing is we're going to be using a method called arrays.binary search, which looks into the array of hay bales, which is sorted, and it finds the index in which the value at that index is equal to a or equal to b. So we can set the index, the a index, as arrays.binary search. So it's going to be searching inside the array hay bales for the integer a. And we can call this a separate integer. And this is going to happen the same for B, but instead we're going to call it B index, and it's going to be looking for the integer B. And we can do sb.append b minus a plus 1, and we'll also have to append a new line at the end. System colon sb should print out. Actually, we have to do print since there's already a new line added at the end. So if we do it like this, it should work, but it does not. Okay, let's see. This is the wrong backslash. Let's see. So it's 2, 3, 4, 6, 3, 3. So we got the first one right. We got the second one wrong. Third one wrong. Fourth one wrong. Fifth one wrong, and sixth one wrong. So what did we do wrong? Well, the thing is, the method arrays.binary search returns a positive integer if there is an index at which the value equals a, or the value equals b. But if there's no value in the array that equals this integer, then it's going to return a negative number, and this negative number is going to represent um, the index of where that integer would be if it existed in the array, and it's going to be added as a negative number. So what we need to do is we have to do if a is less than 0, a equals negative a, so a times negative 1 minus 1. And we have to do this minus 1 because we remember that even though it returns the index at which it would be at if we subtract it by negative 1, we still don't want to count that index in our final calculation. So we have to count the number before that, at the index before it, since this number doesn't actually exist in the array. And then if b is less than 0, b equals, and remember that b is going to be the second biggest number, and what this means is that instead of, so when we subtract a by 1, all it's doing is it's setting the index at the appropriate value, because when we uh, uh, when the array doesn't contain the value of a, it's going to return a negative number that's like, it's not going to be indexed like 0 and up to n. So we have to subtract 1 to compensate, but here we have to subtract 2. Because when we subtract 2, that extra minus 1 is going to be from making sure that it's the value before it, since this value doesn't actually exist in the array. So to recap, for this one we have to subtract 1 because of indexing. When we have a negative value, the lower index always has to be subtracted by 1, and the higher index has to be subtracted by 2 to get the actual index, because these values don't actually exist in the array. And now when we submit it, it should work. Got 2, 3, 4. Wait. That's strange. Did it not save? 2, 3, 4, 6, 3, 3. Okay, let's see. Okay, we stored it. Let's try printing out Haybales. Oops. Arrays dot. It's not toString. It stored it correctly. Yeah. So let's look at the indexing. be getting the values correctly. It's very strange. Still, colon a plus plus. So 2 to 3, 2 to 4. Oh wait, I found the issue. Sorry. That was me not being intelligent. So A index, and then we switch it to A index. A index, index, index. Let me change all these to indexes. Okay, now it should work. Sorry, I did not catch that. Yeah, 223410. So that's correct. Let's take out the arrays dot to printing it out. Let's make it out.print, out.print. And remember to close the input and output files. Okay, let's try submitting it. Uh-oh. Ignore those files. That's strange. Anything else? Yeah, it should work. Hopefully. Yeah, it's a bit slow, but it does work. Yeah, so all the test cases passed. And yeah, that's basically how you solve it. You just use this function called the arrays.binary search, and that can find the index of a certain integer in an array extremely fast. And yeah, I hope this video helped, and thanks for watching.